Hello everyone, once again welcome to PM Networking. Guys, today in this video we are going to configure GRE Tunnel, right? In this video you will understand how to make communication possible between two sites by configuring tunnel, right? So whatever we had discussed in theory, right, I am going to show you each and everything practically. Okay, so as you can see over here, this is my GNS3. Let me drag and draw some router R1, R2, R3. Let me change the symbol of this router. Symbol. Okay, wait. Okay, so suppose this is my ISP. This is my ISP. Let me change the host name as well. Host name is ISP. This is my ISP router and this is my 2-edge router, right? This is my 2-edge router. Let me connect through serial link, serial 2/0. Serial 2/1 to serial 2/0. Okay, and let me drag and draw some layer 2 switch as well, Ethernet switch. So suppose this is my site 1, this is my site 1 and this is my site 2. First Ethernet 0/02. Okay, so this is my topology. This is my topology. This is my two side. This is side 1 and this is side 2. And suppose we have some user. Suppose we have 100 user in this LAN and 100 user in this LAN. Okay. /1 0/2/0. First Ethernet 0/0. Serial 2/0. First Ethernet 0/0. So this is my topology. Fine, let me turn on the device. So here I am going to configure IP 15.1.1.15.1.1.1 and here I am going to configure 16.1.1.1. okay, this is my public IP address for here and this is my public IP address for here. Okay, in LAN suppose I am configuring IP 10.1.1.0/24. okay, and here me duplicate and 10.1.1.10.1.2.1 over here, 2.0 over here, 2.0 over here. Okay, so guys, this is my topology. Let me configure IP first. Go to R2. We are going to discuss each and everything step by step, don't worry. Configure terminal interface. First Ethernet 0/0, no shutdown. IP address 10.1.1.1 255.255.255.0. exit interface serial 2/0, no shutdown. IP address is 15.1.1.1 255.255.255.0. exit. We configure IP on ISP router and we don't have access of ISP router, right? Let me configure IP. After that we will not configure anything on ISP router. Interface serial 2/0, no shutdown. IP address 15.1.1.2 255.255.255.0, right? Exit interface serial 2/1, no shutdown. IP address for here is 16.1.1.2 255.255.255.0. okay, now I don't have access of ISP router. Okay, so let me configure R3. interface serial 2/0, no shutdown. IP address is 16.1.1.1, 255.255.255.0. Exit interface fast ethernet 0/0, no shutdown. IP address 10.1.2.1, 255.255.255.0. right? IP configuration is done. Now as you all know, we need to configure one default route toward ISP over here on R3 and on R2, right? So let me configure a default route toward ISP 0.0.0, 0.0.0, and either you can use exit interface or next hop IP address. So I am using exit interface, right? So you can see the routing table of R3. So IP route. So yes, there is one default route. Let me configure default route on R2. IP route 0.0.0, 0.0.0, and exit interface is serial 2/0, right? So IP route, so there is one default route, right guys? Now let me show you 15.1 is able to ping 16.1 or not. So yes, 15.1.1. Ping 16.1.1.1. So will it ping? Yes, it will ping, right? Because this is 15 network and 16 network is directly connected to ISP router, right? So this is your condition, right? Your public network must be reachable to each other, right? This is the responsibility of ISP, by the way. Okay, now is your LAN able to communicate with your other LAN? Ping and source 10.1.1.1. no. Answer of this question is no, it will not ping. So I am going to create one tunnel, right? Going to create one tunnel. So let me create one tunnel over here. Interface tunnel 1. IP address is 192.168.10.1. Subnet mask is 255.255.255.0. Suppose this is the IP address of my tunnel interface. After that, tunnel source. Tunnel source is tunnel source. Tunnel source is 15.1.1.1, right? Tunnel destination. Tunnel destination is 16.1.1.1, right? Tunnel source is 15.1, tunnel destination is 16.1. Let me configure the same thing on R3 as well, right? To create tunnel, we have discussed in theory. Interface tunnel 1. IP address is 192.168.10.2, 255.255.255.0, and tunnel source is 16.1.1.1.1. tunnel destination is 15.1.1.1.1, right? Let me show you the routing table of this router. So IP route. So IP route. So there is one tunnel interface, right? You can see this network connected to tunnel 1. Fine. Now let me capture this link, right guys? I am going to capture this link now. Okay, in white shark. Ping 192.168.10.2. So am I able to ping my tunnel interface, my other side tunnel interface? Yes, but you can see guys, here is my traffic, right? Where is ICMP traffic? This is ICMP traffic. Let me open it. Here you can see this is ICMP traffic. Fine, this is ICMP traffic, where in IP address source is 192.168.10.1, destination is 192.168.10.2. after that GRE encapsulation, right? So when router will order traffic from tunnel interface, right, it will encapsulate the traffic. It will consider the ICMP and this IP header as a data. After that the header, and then again IP header. In IP header, source IP is 15.1.1 and destination IP is 16.1.1.1, and 15.1 and 16.1 is directly connected to this router. So that's why we are able to ping my other tunnel interface, right? Okay, but will my LAN user communicate? And source 10.1.1.1. So will my LAN user communicate? So answer of this question is still no. Still no. Guys, you can see here is traffic, right? This is ICMP traffic. Let me close it. This is my ICMP traffic. 10.1 is generating for 10.1.1 is generating for 10.1.2. Let me close it, right? This is ICMP traffic, and you can see, is there any GRE encapsulation? No, right? Directly your traffic will out from serial 2/0, right? So source IP is 10.1.1 and destination IP is 10.1.2. But in the ISP router there is no routes for 10 network, right? So that's why your traffic will drop on ISP router, right? Now what you need to do over here is you need to configure a static route over here, right? Let me configure one static route over here. Definitely I will not configure a static route. First I will configure, then I will remove a static route, and then I will show you how to configure IGP protocol as well, right? First of all, IP route, and let me advertise 10.1.2.0 255.255.255.0 and exit interface is tunnel 1. Fine. So guys, you can see show IP route. In their routing table there is one static route for which network? For 10.1.2.0/24, and exit interface is tunnel interface, right? Now this router will encapsulate, right? GRE header will add. In the same way, let me configure a static route over here as well on R3. So IP route, and let me do a static routing for 10.1.1.0 network 255.255.255.0, and exit interface will be tunnel interface. Okay, now guys, will my LAN user communicate? So yes, now my LAN user will communicate, right? Ping, yes, ping is successful, right? Now my LAN user is able to communicate, but I don't want to configure a static routing, right? So let me remove static routing over here. No IP route 10.1.2.0, subnet mask is 255.255.255.0, and exit interface is tunnel 1, right? Let me run same command on R3 as well. Configure terminal, no IP route 10.1.1.0 255.255.255.0 and tunnel exit interface is this one. Now let me configure one IGP protocol. Either you can configure OSPF, RIP or EIGRP, right? I am going to configure EIGRP, right, on this router on R2. Okay, so go to R2. After that, router EIGRP AS number 100, and network, let me advertise 10 network. And guys, always remember, never, you can't advertise one link in routing protocol, in IGP protocol, right? So you are not allowed to advertise WAN link, right? So which network I am going to advertise? 10.1.1.0. Wildcard mask is 0.0.255. Okay. So here is router EIGRP 100 and network 20.1, sorry, not 20, 10.1.2.0, right? Wildcard mask is 0.0.255 and tunnel interface, right? So tunnel interface is 192.168.10.0, wildcard mask is 0.0.255. In the same way, let me advertise tunnel interface of tunnel interface in EIGRP over here as well. So network 192.168.10.0, 255.255.255.0. Now, okay. Wait guys, no, let me define wildcard mask 0.0.255. Fine. Now you can see this router will send one hello message, right? This router will send hello message. See, 10.2 is sending this one. So let me open this message. 10.2 is sending 10.1. Okay, let me open another hello message. So this one. Who is sending this one? 192.168.10.1 on multicast address, right? But this hello message is encapsulated in GRE, right? It is a GRE. This is GRE header, and in IP header you can see protocol number, protocol field. In IP header there will be one protocol field, and in protocol field you can see value is 47, protocol number of GRE encapsulation protocol, GRE encapsulation protocol. And here, okay, so this actually this message, right? And here guys, here you can see one more thing, right? First of all, here is your ICMP EIGRP message, right? Here is your hello message. This is your hello message, right? This is IP header. In IP header, source IP is 192.168.10.1, right? Tunnel interface IP address, because we advertise tunnel interface in EIGRP, and destination IP is multicast address, right? After that, you can see here is GRE. And in this IP header, what will be the protocol number? Protocol of EIGRP, right? Protocol of EIGRP. And in this IP protocol, protocol number is 47, right? So now this user can communicate. So yes, answer of this question is yes. Now ping 10.1.2.1 and source is 10.1.1.1. So yes, now LAN user is able to communicate. Actually, what is happening over here, guys? Understand? Actually, when I advertise, right, GRE tunnel interface, right, tunnel interface in EIGRP. So EIGRP hello message will send through tunnel interface, So what is the source IP address? What will be the source IP address? The IP address of tunnel interface, that is 192.168.10.1, right? Tunnel interface. After that, GRE encapsulation, and here is your EIGRP hello message, right? Here is your hello message. So now this router will consider this all information as a data, right? And again this router will encapsulate this data in IP header. Here the source IP will be 15.1 and destination IP will be 16.1, right? You can say, okay, this was my hello message. You can see here is source is 16.1 because R3 tunnel R3 router is 192.168.10.2 is sending this hello message, right? So you can see here source is 16.1 and destination is 15.1, right? And ISP router is reachable to 15 and 16 public IP, right? So that's why these LAN are able to communicate with this LAN user. Okay, so hope guys it's clear to you now how to configure GRE tunnel, right? In next video we will discuss what the problem over here, right? What the problem? Suppose we have one more site, right? Then we need to create one more tunnel over here, right? And suppose we have 100 site, so we need to configure 100 tunnel over here, right? So we will discuss about this thing in next video, right? So that's all for today. If you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. Thank you. Thanks for watching.